Hello, everyone. My name is Wang. I'm very happy today to share with you my research, weight perception and controlling experience in lauded virtual rehabilitation, effect of biased weight feedback and modulated movement. This is the overview of this presentation. It includes first introduction, and then the related works, and also the game overview, and also experiment that I conducted. The result and discussion will also be presented. Finally, there will be a conclusion. First, I'll give you a short introduction. Virtual rehabilitation in the recent years have attracted lots of researchers' attention, and lauded exercise is an effective training method widely used in workouts and physical therapy. It helps to strengthen the body muscle and improve motor control in targeted body areas. An example can be found in the right picture of lauded exercise in combination with VR. For the lauded exercise in VR, it often requires wearing external devices and exoskeletons. However, it could be very challenging to provide users with the physical load on their body in VR because the external load can easily cause fatigue, and also the user's feeling of control may also be impaired. So it is very necessary to maintain a good user experience of VR lauded movement. Weight perception and experience of control are the two main research questions of the study. Weight perception is a user experience that makes the interactions more realistic in VR, and it is highly related to the object properties seen by the VR user, the user's prior sensory motor experience, and also the movement modulation, which produce a mismatch between the real and the virtual motion. Experience of control refers to the user experience of feeling in control of one's action and their corresponding outcome. It is a critical consideration in human-computer interaction, and it plays a significant role in driving the motor rehabilitation process of patients undergoing motor dysfunctions. Experience of control may also be affected by the movement modulation. So it is worth to investigate the weight perception, how can it be reduced, and the experiments of control, how it can be influenced by the lauded. In the literature, movement augmentation is a kind of movement modulation, and is often compared with movement reduction. Movement augmentation extends the user's movement ability by exaggerating their virtual movements in the virtual environment. Movement augmentation holds the potential to reduce fatigue and improve user experience for the lauded movement. It was previously considered to reshape the weight perception of the users, and may also improve the feeling of control because the virtual motions were visually extended. So the relationship between the lauded movement modulation and the experience of control has not been fully explored in the literature as well. Biased weight feedback and the weight perception. First of all, providing suitable weight feedback for physical load is important and essential for many VR interactions. The size weight illusion is one of the most important weight perception. It refers to the smaller object in the virtual environment can be perceived heavier than the larger object which have a similar weight. Biased weight feedback refers to the visually scaled reference weight feedback of a controlled object in the virtual environment. And weight perception has also very close connection with one's controlling experience, especially in the action preparation process and the prediction process. Therefore, this research aims to explore how lauded movement modulation with biased weight feedback influence experience of control and the weight perception in VR. This is the overview of this lower limb rehabilitation exercise game. In the real world, the users have to perform a lower limb lauded exercise. They have to wear a head-mounted display as well as a pair of ankle weights attached on the left and the right foot. With the two white trackers attached on the top of the foot, they are able to control a virtual hammer in the virtual environment, and they are required to repeat 8 movements on the left and the right legs. The biased weight feedback in this study refers to by decreasing or enlarging the size of the feedback after the user exercised with standard feedback. In specific, the reduced weight feedback refers to the feedback of V2 is adjusted to V1 in the second round. And the enhanced weight feedback refers to the feedback of V2 is adjusted to V3 in the second round. In this study, movement augmentation is achieved by altering the virtual hammer raising height according to the real foot raising height and the scale factor X. In this study, the augmentation of the scale factor is determined as 2. So the virtual hammer raising height is multiplied twice in that of the real foot raising height. For the task design and the procedure of the study, it is actually the 2 multiplied 3 factorial design and includes 6 different tasks. In each task, the first round of exercise for each subject is always the same. The subjects have to wear the ankle weights of W2 with the standard weight feedback of V2 without movement augmentation. And in the second round of exercise, the participants have to wear W2, but with biased weight feedback, without movement orientation, or with movement augmentation. For the participant, the study includes 12 healthy participants, and the data collection analysis includes weight perception, experience of control, perceived exertion, and also the motor performance in terms of task completion time. First, this is the result of weight perception. We found that augmented movement with reduced weight feedback produced the lightest weight perception. And it is possible to present lower limb virtual movement using reduced weight feedback together with movement augmentation to help users lighten the perceived heaviness from the external load, such as rehabilitation devices or exoskeletons. However, additional consideration should also be paid as weight perception of using enhanced weight feedback S2 may be held heavier than using standard weight feedback. Then it is the result of the feeling of control. We found that augmented movements produce lower feeling of control than those without. With movement augmentation, enlarging virtual object size during the test helped to generate a slightly better feeling of control. And they suggest that when the user's movements are exaggerated, using a larger controllable object may help to produce a better experience of control than without movement augmentation. So it might be possible to design motor tasks by using enhanced weight feedback together with the augmented movements during tasks to help the users generate a better feeling of control. For the perceived exertion and completion time, we found that the augmented movement produced less perceived exertion but more completion time. The augmented movement, which decreases the raising height of the user in the physical world, was experienced less physically demanded in lower limb trinity tasks. For the augmented movement, which results in less precise movement, it requires the user more time to be completed. In summary, we first found that weight perception decreases by around 10%, less than that of the real weight, by using reduced weight feedback with augmented movement. And second, the experience of control of the whole task can also be impaired once lauded movements are augmented. The contribution of this study is first, it provides new insights into how weight perception can be lightened in VR exercise-based applications by combining augmented movements with biased weight feedback. And second, it could be very beneficial for deepening our understanding of how lauded movement modulation influence the experience of control, which advances the crucial experience of human-computer interaction in VR. Third, this study provides a practical reference for researchers and designers who intend to improve the user experience of VR applications for lauded movement exercise, such as virtual rehabilitation by users wearing external devices and exoskeletons. So this is the end of this presentation, and thank you for listening. And if you have any questions, please let me know.